How is a radical mechanism related to breaking up? In general, a radical mechanism consists of 3 steps. In the initiation step, a non-radical forms 2 radicals. In the propagation step, a radical reacts with a non-radical to form a new radical and new non-radical. Usually there's more than 1 propagation step. Finally, the termination step involves 2 radicals reacting to form a non-radical. In an alkane halogenation reaction, an alkane reacts with an halogen, X2, to form an alkyl halide. So stop the video and review the mechanism of this reaction, and then identify what happens in the next step. Note that in the initiation step, 2 radicals form from a non-radical. In the 2 propagation steps, a radical reacts with a non-radical to form a new radical and new non-radical. So what happens next are the 2 propagation steps occur over and over and over again. Ideally, you do not want the termination step to occur because that will stop the reaction. Let's compare alkane chlorination to alkane bromination. Stop the video and compare the product distribution. What conclusion can you draw? Here is the conclusion you can draw. Here are the initiation and propagation steps for the alkane halogenation reaction. And here's the reason that bromine is selected whereas chlorine is not. Here's an example of an alkane bromination reaction. Stop the video and answer these 3 questions. The answers are, and the product is. So let's practice these alkane halogenation reactions. Stop the video and predict the major product or products of each reaction. So here are the answers. Note that this carbon does not have a CH bond. We looked at alkene addition reactions earlier in this course, so just to review, stop the video and predict the product of each reaction. And the answers are: the top reaction occurs via a carbocation intermediate and is called a Markovnikov addition. The bottom reaction occurs via a radical reaction, that's the non-Markovnikov addition, or anti-Markovnikov addition. So let's take a look at how the anti-Markovnikov product is formed. The first step in the radical mechanism is the initiation step. The oxygen-oxygen bond in the organic peroxide breaks to form 2 RO radicals. The next step in the radical mechanism is the propagation step, in which a radical, in this case the RO radical, reacts with a non-radical. Stop the video and figure out whether the non-radical is HBr or the alkene. It turns out that in that first propagation step, the RO radical reacts with HBr to form an alcohol in the Br radical. In the second propagation step, the Br radical reacts with the alkene to form another radical, plus HBr. So stop the video and use curved arrows to show each product is formed and determine which radical is formed in the second step. So here are the answers. The radical product that forms is a secondary radical, which is more stable than a primary radical or primary allylic radical. Radical stability follows the same trend as carbocation stability. There is a third propagation step in this radical mechanism. The secondary radical reacts with HBr to form the anti-Markovnikov product in Br radical. Stop the video, use curved arrows to show how each product is formed, then figure out what does the Br radical do next. Here are the answers. Earlier we looked at the alkene halogenation reaction, which is an addition reaction. However, changing the reaction conditions will result in a substitution reaction in the allylic position. This second reaction occurs via a radical mechanism. The allylic carbon is the carbon adjacent to the vinyl carbons. In the allylic bromination reaction, the reactants are the alkene, Br2 or NBS. Br2 or NBS produce the Br radical. Here is the initiation step in the allylic bromination reaction using NBS. In the first propagation step, the Br radical reacts with an alkene to form an allylic radical. Stop the video and use curved arrows to show how this reaction occurs. Here's what happens. In the second propagation step, the allylic radical reacts with NBS to form the product, and another radical. The allylic radical can also react with HBr to form the product. So let's practice. Identify the allylic carbon in the reactant and predict the product of this reaction. And the answers are: practice makes perfect, so stop the video and answer these questions. And the answers are: ozone blocks ultraviolet radiation from the sun. However, Freon, a fluorochlorocarbon, which was used in refrigerators and air conditioning units, depletes ozone. So practice your curved arrows and show how each step occurs.